This video is part of a series of exam question walkthroughs looking at questions that are to do with the AQA A-level chemistry required practical activities. So this video is not actually about the main practical itself, but it's about making a calibration curve, which is something that you need to be able to do in order to perform this practical. Before I walk you through how to handle this question, pause the video and have a go at answering it yourself. So the reason that we produce a calibration curve is that it's very common for pH probes to actually give slightly inaccurate readings. Now that could be a systematic error, so that could mean that your pH meter is always saying a value that is 0.1 higher than it should be, for instance, or it could be slightly different in different parts of the range. So it may be that it reports high pHs as being too high and low pHs as too low. And whichever one of these issues we encounter, a calibration curve can help us because it allows us to adjust the readings that we're getting from the pH probe to actually reflect the accurate pH of that solution. So in order to do this, you're going to need a minimum of 3 pH buffer solutions. And those pH buffer solutions have known accurate pHs. You buy them and the company that sells them to you says, oh, this is exactly pH 2.00. And we want to cover as much of the range of pHs as we can. So you might only have 4, 7 and 9 in school. Sometimes you can get ones that are a little bit broader than that, but basically you can only guarantee that your calibration curve is useful in the range of pHs that you've actually used to make it. So you want to be as broad as you possibly can. So all you're going to do is you take your pH probe and you use it to measure the pH of the first solution and record that, and then you rinse it off with distilled water. And the reason you're doing this is because you want to avoid contamination, you want to avoid there being sort of residual solution left on the pH probe and that contaminating your next reading. So you give it a good rinse in between times, and then you measure your second solution and you rinse it off with distilled water, and then you measure your third solution and you rinse it off with distilled water before you put it back in the storage buffer if it has one. So now you've got 3 sets of data. You've got the actual pH that you know that this solution is, and then the pH that your pH probe says that it is, and you've got those for all 3 solutions. So having done those, you can make your calibration curve. So this is where you're going to plot the graph where you've got the pH probe reading on your y-axis and the original accurate pH value on your x-axis. And it's very likely that this will be a linear graph, even though we call it a calibration curve. That's just the name of the graph. So once we've got that, we can draw a line of best fit through our data. And then for every reading that we make in the titration, you're going to refer to that line of best fit. So, you know, you might read off that your pH probe is saying, oh, this is a pH of 9.10, but actually when you track across to your line of best fit, you say, oh, actually, that's a pH of 9.00. And so you add an extra column to your table and you adjust your results accordingly. Thank you very much for watching, and I hope you're now confident that you could describe how to create a calibration curve. If you're finding these required practical videos useful, then don't forget to like and subscribe for more A-level chemistry content coming soon.